Okay, fam, we made it. We're on the last video. I don't know about you guys, but I'm feeling really tired. So hopefully you've taken sufficient breaks in between each of these videos. I know that this has been a lot to go over at home, and if you've made it this far, I just want you to know that I really appreciate that, and I'm proud of you and impressed that you stuck with it and you made it through, and it makes all this work worth it, and it's going to make things easier when I see you again in class. Okay, so brief walk down memory lane. We have looked at the basics of a two-way table. We went over marginal distributions. And then we talked about conditional distributions because marginal distributions don't tell us anything about the relationship between two categorical variables. And what we know from page 1 is that if we're going to look at two categorical variables, it's usually because we think that there is a relationship between the two. Conditional distributions help us describe what the relationship is or see the relationship. So to put it all together, we are going to learn how to describe with a graph and with a written response whether or not there is a relationship between two variables. Now, instead of saying relationship, the words that we use are independence or association. Independence or association. So you could be asked if there is a relationship two different ways. Both of these questions are asking, is there a relationship between the two variables? Now, the first one may be, are gender and type of car independent? The second one may be, is there an association between gender and type of car? So let's talk a little bit about what these words mean. Are gender and type of car independent? What that means is that there is no relationship. No relationship. One variable does not influence the other. So no relationship, one variable does not influence the other. So it does not matter what your gender is, that will not influence what type of car you drive at all. The other one is there an association between gender and type of car? So that is the opposite. This one is saying variables are related. It's going to write are relation. Variables are related. One variable influences the other. And we already know that this is true for this table you see below. These variables are not independent. These variables have an association. I'm hoping that you're seeing that these two things are opposites. These two things are opposites. So independent means no relationship. Association means there is a relationship. They may ask it one or the other ways. So they'll either ask, are they independent? Or they will ask, is there an association? You just have to make sure that you keep straight which one, what each one means. Okay, so let's see how we can describe whether or not there's independence or an association with our table and segmented bar graph. So in this lesson, we're going to learn how to make a segmented bar graph. Okay, so first things first, we have to identify what we think is our explanatory variable, and we already did that on page 1. And on page 1, we have this arrow drawn here that says we think that gender influences type of car. So I am going to draw that arrow because that's going to help me with my segmented bar graph. Sorry, I didn't mean to use this color, so I'm going to cover it with a different one. Okay, there we go. Okay, so here's where this arrow becomes very helpful. Number 1, where you are starting at, the part where you start your arrow, this is always your explanatory variable, and it goes on the x-axis. So that's the first thing that you get from this arrow that is very helpful. You start at your explanatory variable, and it is that you put on the x-axis of your segmented bar graph. So I'm going to go over here to my segmented bar graph. I have 2 variables I need to put on the x-axis. So in this first column of boxes, I'm going to label that male, and in the third one, I'm going to leave space in between. I'm going to label that female. Then underneath that, I'm going to label the whole thing gender. So your x-axis is gender, and you're going to have 2 different bars. You're going to have a bar for your male drivers, and you're going to have a bar for your female drivers. So first thing that this arrow tells us that is very helpful is what we put on the x-axis of our graph. Then the second thing that it tells us that is important is the direction that your conditional percents are going. So that means that you are going to find the conditional percents for the males, and then you are going to find the conditional percents for the females. I think I want to use a different color. So all the question says to me is our gender and type of car independent? And where I would need to start is, okay, which one of these is the explanatory variable? Draw the arrow and determine what would go on your x-axis and which way your conditional percents are going to go. Well, we've already calculated these conditional percents. We did this on the previous page. So I'm going to find the one that matches. That's this one. The shading on my bars on the previous page matched that set of arrows. It's going this way. So I'm just going to pull those percents out of this table. I'm not going to calculate them again. So 35% of males drove an SUV. 65% drove a sports car, 75% of females drove an SUV, 25% drove a sports car. And like I said, I just pulled those from the previous page because I already calculated them. Okay, now we're going to use these 2 rows here to make our segmented bar graph. So we're going to use the data in this green row to make this segmented bar graph. I'm a little bit reluctant to do this, but I'm going to do it just to help. So this is going to match the data here. The y-axis on a segmented bar graph is percent. So if you'll notice, there's 10 little boxes here. That means each box represents percent. And every segmented bar graph, the y-axis is percent. Every segmented bar graph, y-axis is percent. Okay, well, in this green row, these percents, 35 and 65, add to 100. We want to graph the different categories. So this first category is 35%. So what we do is we come over to our graph. We know that this box is 10, 20, 30. 5 would be halfway. So now I'm going to shade this in. I think I'm going to do little bars. I'm going to give this section its own pattern. And then I'm going to lightly shade in this section. Okay, well, we have to make sure that somebody looking at this segmented bar graph knows what we're talking about. So I'm going to make a key over here. This is my key. The shaded part represents sports car. This is now 65%. You can count it up. 10, 20, 30, 40, 50, 60. Halfway is 65. So this represents sports car. And then my other pattern represents SUVs. So this is a visual representation of how many males drive an SUV and how many males drive a sports car. Okay, now I'm going to do the same for the females. This is the color that I should have used here. So 75% of the females drove an SUV. So that's what I'm starting with. I go 1, 2, 3, 4, 5, 6, 7, and then halfway would be 75. And I'm going to continue my pattern. You can use different colors if you want. If you hate the idea of using a pattern and you just want to leave them empty, that's fine. If you wanted to leave them empty and write SUV here and sports car here, that would be fine. Segmented bar graphs are very similar to regular bar graphs in that you have freedom to visually make them how you want them. So I've just shaded mine in. I think maybe if I had to do it over, I might just go in and write what the different categories are. In fact, I think I might erase and do that. So instead of having a key here, I could erase that key and just fill the different categories in on the bar graph. And that's easy for me because I used highlighter. So I could just go in here and say, okay, this is SUV on both of the graphs. And this is sports car. So whichever way you prefer, that's what you are going to use. I'm not sure which way I prefer. Maybe I prefer this way. I can't really tell. For some reason, this shading isn't bothering me, but that shading was. Okay, so this is your segmented bar graph. This y-axis represents the percent, and then each of your bars make up your category for the explanatory variable, and then the different sections of the bar represent the other variable. So how can we use these to determine if there is a relationship? If these are different, there is a relationship. So up here, I'm going to say in the association bullet point, if the percents and or bars are different, that means there's an association. If the percents and or bars, and these are the bars that I'm referring to, are different, there is an association. So we can hopefully see here, I'm sorry guys, I'm having so much trouble with how I want to represent this. It's really very silly. I apologize. We can see here that these bars are definitely different. And that the percents in the table are definitely different. I'm just fixing my table one more time. I think that I might be as annoyed as you guys are, so I apologize. What's this one? SUV. Okay, so let me show you or explain to you what it would look like if they're independent or they have no relationship. So the percents in the table would be the same. And I mean exactly the same. And the bars in the segmented bar graph would look the same. So I'm going to start with that one. Segmented bar graph. I shouldn't say segmented bar graph. This was going so well until just a couple minutes ago. The bars in the segmented bar graph look the same. So if they're independent, that means that the bars in the segmented bar graph look the same. That also means that the percents in the table are the same. And exactly the same. Not just close, exactly the same. So let me show you what that would look like for the data that we have. So we have males, female, and then we have SUV, sports car. If these were independent, what it would look like is 35% of males drive an SUV, 65% drive a sports car. 35% of females drive an SUV, and 65% drive a sports car. So what this table is telling you is that gender does not influence what type of car you drive. There is no difference between how many females drive a minivan and how many males drive a minivan, or how many females drive a Tesla and how many males drive a Tesla. If there is no relationship, that means that the results for each gender should be exactly the same. If they're not exactly the same, that means that the variable does influence the other. And I'm hoping that that makes sense in your brain. So I'm going to say that one more time. If there is no relationship between gender and type of car, then these percentages inside the table would have been exactly the same. The same amount or the same percent of males would, or the same percent of males and females would drive an SUV. And the exact same percent of males and females would drive a sports car. There would be no difference in the percentages that drove each. So I'm hoping that makes a little bit of sense. If these percents were the same, then obviously these segmented bar graphs would be exactly the same. They would both look like this, and the only difference would be that this one is colored in a light or in a different color than this one. So if there is no relationship, percents are exactly the same, the bars in the segmented bar graph look exactly the same. If they are different, like we have in our situation here, that means that there is a relationship or that gender does influence what type of car you drive. So that is how we visually represent whether or not there is a relationship between two categorical variables. You can use a table or you can use a segmented bar graph. So the last thing that we need to talk about is how you describe that relationship. So these bullet points here are like the evaluating a claim bullet points. You want to make sure that you are including all of these things when you answer these questions above. So you want to make sure that you include all of this when you answer a question like in these bullet points. So I'm going to show you how you would respond. This first one is how you would respond to are gender and type of car independent. That's why these are highlighted in the same purple color. So if the question is, are gender and type of car independent, this is how you would respond. So gender and type of car are not independent. Remember, independent means there's no relationship. So this means that they are not independent. The segmented bar graph shows that you are more likely to own an SUV if you are female. You could also say you are less likely to own an SUV if you are male. You could say you are more likely to own a sports car if you are male. As long as what you are saying is true, it doesn't matter what relationship you highlight. So the first thing we have to say is variable 1 and variable 2 are or are not independent. Then we reference the table or the segmented bar graph, and we have to make a statement that's more or less likely. You have to use more or less likely. Then the last thing that you do is give specific values from the table. So because I said females are more likely to drive an SUV, those are the numbers that I'm going to pull from the table. 75% of females drive an SUV, whereas only 35% of males do. So I've done all the things that the bullet points tell me I need to do. They are or are not independent. The segmented bar graph shows and make a more or less likely statement and then give specific values. This part where I said females are more likely to drive an SUV, that's not the only thing you could say. You could say you're more likely to own a sports car if you are male. And then you would use that data. 65% of males drive a sports car, whereas only 25% of females do. Now we have one other thing that they could have asked us, is there an association between gender and type of car? So I'm going to highlight that in the same color. Now they're not going to ask you both. There's never going to be a question that asks both questions. I am just highlighting what you would do in either case. So this is what you would do if the problem asked you if they were independent. This is what you would do if the problem asked you if there is an association. So you use the same bullet points. You say there is or is not an association between the variables. So this time there is. There is an association between gender and type of car. The segmented bar graph shows, and then I'm taking the exact same information that I used in the last one. You are more likely to own an SUV if you are female. 75% of females drive an SUV, whereas only 35% of males do. So I'm going to zoom out because there's a lot of information on this page. So I'm going to recap it. I'm going to ask you to do the check for understanding on the following page. And then that's it. You are done for all of these lessons. I shouldn't say that's it like it's been a quick little adventure, because it definitely has not. This video is already way longer than I thought it was going to be. I wonder if that's because I redid my segmented bar graph 17 times. I apologize for that. So, we talked about how we're looking to see if there's a relationship between two categorical variables, and the way we discuss that relationship is either talking about whether they're independent or whether they have an association. You will be asked one or the other. It'll say, are the variables independent? Or it'll say, is there an association between the variables? These two things are opposite. Independent means no relationship. Association means relationship. You use your arrow as your helper to figure out how you label your segmented bar graph and what you put in the different bars or boxes for your segmented bar graph, or how big you make those, I should say, instead of what you put in. Then, depending on what these look like, you determine if there's a relationship or not. If these are exactly the same, there's no relationship. Your one variable does not influence the other because the outcome was exactly the same. If these are different, that means there is a relationship because the outcome was different. Then these are your sentence frames for answering whatever type of question they give you. Remember, you want to hit every element in the bullet points. So I know that having only one example may be a challenge, but I want you to use this example to try this check for understanding. I really want you to give it your best effort to really go through and see if you can work out this problem without having to watch me walk you through it. Now, when I show you the solution, I'm not going to walk you through it slowly. I'm going to show you the solution, go through it, and hope that if you're struggling, that's enough to help you. If it's not, you can bring it to class, and when I see you again, I can answer any questions that you have. So this is the point where you should pause the video, try to work out this problem, come back and check your answer. Okay, the setup for this problem is that an administrator at a large university is interested in determining whether the residential status of a student is associated with the level of participation in extracurricular activities. Residential status is categorized as on campus or off campus, so you live in the dorms or you live in an apartment or maybe at your parents'. A simple random sample of 100 students at the university was taken. Is there an association between residential status and level of participation in extracurricular activities? So the first thing that we should note is that they are asking, is there an association? So that's the question we're going to answer below. Is there an association? Step number 2 is you need to decide what variable you think influences the other, and then draw the arrow. So I personally think whether or not you live on campus is going to influence how many extracurricular activities you do. If you live at home, you're probably not going to want to drive back to campus to do something extra. But if you're already on campus, you might be more willing to participate in extra things. So I think that the arrow goes this way, which means that when I make my segmented bar graph, this is going to be on and off, and I can label that residential status. The next thing that I would do is go through and find these missing values so that I can calculate my conditional percents. So those missing values are 9, 33, 12, 67, and 19. Okay, I know from my arrow that the direction that I'm going to calculate my conditional percents is down. So I'm going to calculate conditional percents for on campus, and I'm going to calculate conditional percents for off campus. If you go through and calculate those, you end up getting 27%, and I'm not showing work because I'm hoping you've already done this. 52%, 21%. For off-campus, it's 45%, 37%, 18%. The percents are different. So right now I know there is an association between residential status and level of participation in activities. I can now go over and make my segmented bar graph. Not remember, but on this one, you're going to end up having 3 different categories. So for on campus, my first percent was 27. So I count 1, 2, and then I go almost all the way on the third one. So that would be 27%. This little smidgen right here is 3. So if this is 27%, that means that little smidgeroo left over in here is 3%. Then the next one I have to graph is 52. So I'm going to count 5, 10, 15, 20. I don't know why I'm counting by 5s. I apologize. 10, 20, 30, 40, 50. And then I need 2, but I have 3 here. So I'm just going to draw this a little teeny, sminchy, little bit less than that tick mark. So now that's 52, and that makes this last section 21. Okay, so that was kind of a crash course. Now I'm going to show you my detailed answer. So this is now showing my work, how I got those percents. This is my segmented bar graph, and I do have my key. And then this is my response, and I highlighted all of the things that I'm required to include in my response according to these bullet points. So there is an association between residential status and level of participation in extracurricular activities. The segmented bar graph shows that students are more likely to participate in extracurricular activities if they live on campus. 73% of students who live on campus participate in at least one extracurricular activity, whereas only 55% of students who live off campus participate in at least one extracurricular activity. You could also say The segmented bar graph shows that you are more likely to not participate in extracurricular activities if you live off campus. And then you would say 45% of students who live off campus participate in no extracurricular activities, whereas 27% of students that live on campus participate in no extracurricular activities. Okay, I know that that's a doozy. That's a lot of information to take in. So I'm just going to recap and then you're done. Hallelujah, right? So notice you only had to do one thing here, and that was address association. On this previous page, we did independence and association so that you would have an example of how you answer each one. These are the things that you need to make sure that you include. This is the part where I walk you through how to use your two-way table to make a segmented bar graph. And then lastly, this explains what is independence, what is association. I'm hoping now that we've done this, you can see why I would want you to do this lesson at home so that you have all of next period to ask me anything that you're confused on and anything that I did not make clear enough. So, in the meantime, if you have questions, you can send them my way, but otherwise, I hope that this went okay. I'm sorry that this last video is so long. And once again, I appreciate your work. I appreciate all of you guys for sticking with this class. I know that you're choosing to take a hard class, and I admire that about you, and I appreciate that. So love you. Hope that you have a great rest of your weekend. I hope that you have quite a bit left, and I will see you in class.